Let's see. Chapter contents. Chapter 5. Right, chapter 5. And I think we're moving into 5.4,
Yep.
which should be solving equations. And that's where a lot of your test is going to come from.
Well, it just says inverse exponential logarithm functions. 5.5 says equations.
Okay. Then we're going to 5.5. Yeah.
5.4.
Let me see what 5.4 is.
It kind of leads in there.
Let me look and see. That's graphing. Use your calculator for that. Log base 2 of x. That would be log of x over the log of 2. I'm just going with the examples right here. Log 1/2 of x would be the log of x over the log of 0.5. Yeah, that's using your calculator. Hold on a second. I don't know if you remember in calculus, but whenever you see a logarithm and you see a logarithm of a number, that's just like a number, right? So when you do the logarithm of a number, you just go ahead and calculate that, and you have, hold on a second, I'm trying to get everything moved over. There. See, like this example right here, both of these examples. This example right here says f of x is equal to log base 2 of x. Well, I told you that to change base formula, you can't calculate that. So you have to change it. So f of x is equal to the log of x over some number, which is log of 2. Somebody take your calculator and tell me what the log of 2 is. Well, I'll do it right here. I forgot. Log. Oh, of course, cooking. Thank you. 0.301. So really, this is f of x is equal to the log of x over 0.31, right?
Yeah, 301.
Or 301, whatever. My point in showing you this is basically you're graphing you're not graphing two logs, you're graphing f of x is equal to 1 over 0.301 log of x. So you can graph that in your calculator. One of the things you're going to have to start realizing about logarithms, if you take the logarithm of a number, that's just a number. Okay, so you have to treat it like a number, just like distributing it. Some people take the logarithm and distribute. Some people distribute the logarithm. You got to treat it just like a number. And type it in. Y is equal to, wait a minute, I have to go to an act of Congress here. Y is equal to, I'm just going to do 1 parentheses, 1 over, and what'd you say, 0.301 what?
Oh, 2,
hold on.
make it 0.3 for around that.
hold on. 1/3 of what?
30103.
Okay.
Everything else is a bunch of
And then log of x. Close parentheses. And then bracket.
Okay.
So you're going to get that no matter you plug it in or whatever. Now, if you plug in the log of x over the log of 2, it will be rounded a little bit more. See there? There it is up there. Now, if you wanted to find the inverse, you know what to do. You substitute your y with your x, and then you solve for it. Okay? And you have to use your definition of a logarithm. And basically, you get y is equal to 2 to the x. But you have to use your definition of logarithm. Okay? See, right here, change that to x, change this to y, and solve for y. Well, you don't solve it like algebraic, you treat it, you take your definition of a logarithm and rewrite it. And you come up with this. Okay? Or you can just leave it as y is equal to, well, you still have to change it. And then just plug and chug, and then you get the inverse. We can do that next one. Log g of x, we'll do it. G of x is equal to log 1/2 of x. I'm going to do it on whiteboard. Got to find it. Y is equal to log 1/2 of x. Y is equal to log base 1/2 of x. Now the first thing to do is interchange what? X equals log base 1/2 of y. Okay, now you remember the definition of logarithm. Now you got to remember this y doesn't equal that y. This y is equal to log base b of x. And what does that yield? A to the y, or b to the y, sorry. B to the y is equal to what? X. And you have to take that right there. So x is equal to what? Y. And then what? Well, b is what? 1/2. And then what is y? X. So 1/2 to the x is equal to y. Or y is equal to 1/2 to the x power. And that should be what they got.
Yeah.
Okay, so this is a mix between, I don't know when we studied I think there's 2 chapters that we did the y is equal to something something x, and you interchange it, and then solve for y. You remember me going over that? To get the inverse. And that's what you're doing here, but you're adding it to the definition of what? Yeah, you can't do the solving for y algebraically. You have to go to the definition of logarithm to solve it. And then make sure you can graph them. That's the wrong rule. Let's go.
you gonna sign the problems?
Probably not. I'll probably, if I did, it'll be something like that. Those first two. I mean, those two examples is. And to find the domain right here, determine the domain, all you have to do is what? Graph it. Graph it and you'll find the domain. You can see the domain with the graph. Okay, so y'all should be able to do that. My section that I'm really worried about is the last section. That's the one that most of the tests are going to come from. That and rewriting logarithms, definition of logarithm. So let's get to that.
Yeah, you run us out on that. You get like 42 problems or something.
Mm-hmm. Because that's very important. Finding the inverse of an exponential, that's 2 to the y is equal to negative x plus 3. That's not that big of a deal. 5, 4. Section is 5, 5. 5, 5. There it is. Now this is where your I'd say probably 50% of your test is going to come from. Like 30% is going to come from rewriting, and 10% is going to come from definition of logarithm. But definition of logarithm is in this also. So you're not going to get away from the definition of a logarithm. And this is solving, for instance, this one right here. And there's no other way to do these because you have to do them. So there's no shortcut to show you. So we're just going to do examples because there's nothing really I can do about it. And just pull out more problems because you're doing the same one. All right, what's the example? 7 to the x power is equal to 12. Now the first thing I would tell you to do is highlight that thing right there, because that is unusual. Whenever you have an exponent that's a variable, you're either going to have to take the log of both sides, or you're going to have to change the base into the same base. And you can't do the same base with 7 and 12. Why? Because 7 is what? Prime number. So you can forget changing the base. So that means you're going to take the log of what? Both sides. So log of 7 to the x power is equal to log of 12, or natural log of 7 to the x power is equal to the natural log of 12. Either one of these, whichever one you want to do. Now, you've got the natural log of 7 to the x power is equal to what? Natural log of 12. Well, what did I tell you was the natural log of something, or the log of a number? What is that? It's a number. So you've got a number to the x power is equal to a number. That sounds like something. That sounds like something else. Go ahead and take the derivative. I'm sorry. Let me close this calculator. Go ahead and play with it. See what you can do with it. And if you don't, you have a book there. You can look at the book. You're going to have to manipulate it because that's what you're getting used to doing. Manipulating equations. Look at this right here. What'd they do? You tell me. Well, I got it right there. Oh. Let me just go back to it. What is this right here? And you can bring it what? Out front, Hubert. That's right, class. Power rule. So take your handy dandy highlighter when you need to make a note that can come out front. X, natural log of 7 equals natural log of 12. Well, this is a pre-algebra problem. Why? 2x is equal to 4. 2x is equal to 4. A number times a variable is equal to another number. What do you do on both sides? You divide by the number. So what do you do on this one? 7. Now, you could have done your calculator work here, and then had a point something and a point something, and then x times point something is equal to point something, and then divide by this point something on both sides. You could have done it that way. That's a good test question. And if you want to see what they got for an answer, let's see what they got.
If they took it all the way down, it'd be 1.9.
They didn't. They just left it as natural log of 12 over the natural log of 7.
Well, they got the numbers, and then they just put it.
Yeah. Oh, there it is, 1.27. So, what I'm trying to tell you is natural logs and logarithms sometimes can be treated just like what? Numbers. In your algebra. Remember your algebra? You're treated just like numbers. That's a good one to start with. All right, look at this one. This one says 2 to the 3x plus 1 is equal to 3 to the 4 minus x. Write that down. Make sure you get it right, because I'm going to put it on the whiteboard. All right, you done? All right. All right, what does it say?
2 to the 3x plus 1 is equal to 3 to the 4 minus x.
Can we do anything to make the bases the same? Everybody should say what? No. Why do I say no? You can't change 2 and 3. They're both what? They're both prime. So, take the log of both sides. All right, finish it. Using the power rule. I could not sleep last night. I watched 2 or 3 scary movies. Within. You ever seen that one? About this family that moves into this house, and the house is like 20, 30 years old, and there's a kid
that is crazy and deformed and been living in the attic, and nobody knew he was living in the attic, and he crawls around and everybody thinks it's a ghost, and it's not a ghost, it's a crazy deformed man now crawling through the walls and basement and attic. And ended up killing him. But no, it's one of those movies that ends with just credits coming up. Yeah. The teenage girl screams and credits come up. That's it. Oh, I'm going to be faulty. Mr. Strickland needs another invite. Did we lose anybody else? Hope we didn't. Okay.
Thank you.
Yes, sir. All right, so let's bring that out. So it's going to be 3x plus 1 times natural log of 2 equals 4 minus x times natural log of 3. Now what do you notice about the natural log of 2 and the natural log of 3? Nope. Yep. Just so you don't know.
I ain't got a clue what this thing's
What I tell you a natural log of a number is.
A number.
So this is like this. Let's go back in time. How would you solve that? So how are you going to solve this?
Distribute.
What? Which is the natural log. Now you can turn it to a decimal and distribute it, or you can leave it as a natural log and distribute it, however you want to do it. The reason I'm showing you this right here is to show you that you can do the algebra. The only thing different is instead of distributing the whole number, you're distributing the decimal. So I'm going to distribute the natural log because I don't have my calculator and I really don't want to use it. So natural log of 2, 3x, natural log of 2, plus, I'll do this in my head. Natural log of 2 times 1 is natural log of 2. And I'll do that in my head. Equals 4 natural log of 3 minus x natural log of x, 3. Sorry. Now, what is always the rule about your variable? You always want to get the variable on what? One side. Now, I don't want to make my variable negative, so I'm going to bring this negative variable over here. So that's going to be 3x times the natural log of 2 plus x natural log of 3 is equal to, I'm going to bring this over, this positive over here, and that's going to be 4 natural log of 3 minus natural log of what? 2. Now what? Okay, stop. Let's go back in time. Let's go back in time. I'll go back in time. I'll color it blue. Give me a second. I gotta think of something. Nope. Can't think of anything right now. X plus xy is equal to 2. I want you to solve for x. What would you do on that one if you wanted to solve for x? Why would you factor it? To get an x by itself. So when you have something in common, you need to what? What do you do if you have something in common and you're solving for that something? Factor it out. So factor out the x. And that's going to leave us with 3 natural log of 2 plus natural log of 3 is equal to 4 natural log of 3. Oops. For some reason I can't do the eraser today. I don't know why. It's messed up. I have to do this. It's in Russians. Natural log of 3 minus natural log of 2. Now how do I get rid of multiplying by this number?
Say that again.
How do I get rid of multiplying by this number? How do you undo multiplying by a number? Divide it by that number. I was waiting for somebody to say, what number? That's what I was waiting on. Y'all need to take the bait. What number am I talking about? I'm waiting for somebody to say 2. What number? Well, what is 3 times natural log of 2? What is that? A number. What is natural log of 3? And what do you take when what do you get when you add a number to a number? So that in a parentheses is nothing but one big number or little number. So what I'm trying to convey to you, the part of teaching that some people miss, I'm trying to show you that you know how to do the what? You know how to do the algebra since algebra, pre-algebra. You just got to remember that the natural log of a number is a number. And quit treating it like, oh my gosh, I don't know how to do that. So your answer is x is equal to, and somebody needs to crank that out, well, or look in the book, either one. 1.16, 1.17. And I'm not really, this is where you get like calculus, I'm not really concerned with the answer you get. I'm concerned with that right there, that 4 natural log of 3 minus natural log over 3. That's what I'm concerned with, because if you can get that, anybody can punch it in the calculator. Okay? Capiche?
And if you did your logs too early, you end up with a bunch of numbers that you're gonna mix up before you get to the end anyway.
Yeah, especially with decimals. So that's another test question. Okay. I'm showing you test questions. If I see one that I don't like, I'm going to tell you. There's one. There's another test question. Okay. You won't let me move anything. Oh, that's because it's already. Let me blow it up. I don't want people to. I want you to be able to do it without looking. All right, do that one. This one you're going to rewrite before you start, before you actually start doing anything. Using the quotient rule. So using the quotient rule, I could rewrite this as log base 3 of what? X plus 6 divided by what? Equals log base 3 of X. Yes, I'm sorry. All right, are y'all ready for something nice?
Yeah, it's 3. So
Huh? They both, these cancel because it kind of, if I told you before that if you have a same base to an exponent is equal to 2 to the third power, if the bases are the same, they cancel and you get x is equal to 3. Well, this applies here because you have the same base and they both equal to each other and they both have an x component here, so therefore you just set it equal to each other. So that's going to be, I'm going to do it over here, x plus 6 over x plus 2 is equal to x. Now before you do anything, you've got to clear the fraction. So how do you clear a fraction? Multiply through by the common what? Denominator. So I'm going to multiply both sides by x plus 2. And I get x plus 6 is equal to x squared plus 2x. Write that down. I'm going to go to the next, I'm going to go to a whiteboard. X plus 6 is equal to what? X squared plus 2x. On Only thing I can do here is get a quadratic set equal to 0. X squared, what is 2x minus x? Be a positive x, and minus 6. You can use reverse FOIL if you want to, if it'll factor. 2 and 3,
Yeah.
0 is equal to x squared. I'm sorry. I was going to do complete the square. Oh, come on. Two, 3, and then positive 3 and negative 2. Therefore, your answers are 2, comma, negative 3. Now, there's one problem with this. Look at your original equation. 2 and negative 3. You with me? Go back to your original equation. We need to plug in that, what was the number, answers?
2 negative 3.
Negative 3. Uh-oh, we got a problem. What's the problem?
Negative.
You can't take the square root of it. You can't take the log of the what? Negative. So what do you do with that negative 3? Goes away. So your only possible answer is what? 2. Right here, negative 3 plus 2, and a negative 3 right there. Negative 3 plus 2 is negative 1. So you would take the logarithm of, what did I say? Negative 3 plus 6 is 3. Log base 3 of 3 minus undefined is equal to undefined. Doesn't work. So negative 3 is not an answer. So your answer to that problem is 2. Again, another test problem, another test question. You're awful quiet. Okay, here's one that doesn't have a log on the right side. Write that one down. Log of parentheses 3x plus 2, close parentheses, plus log of x minus 1, close parentheses, equals 1. Maybe I'll just sneak that one out. Saw another scary movie last night. Eloise. Eloise? That was weird. It was about this mental institution. You ever seen that one? Huh? It said 2016 or 2017, but it might have been one of those that wasn't in the theater. I don't know. But it was a pretty good movie. It was about. It started off with this guy's father dying and leaving him like $1 million, but he had to go to the insane asylum's administration building to get his aunt's death certificate because he would get all the money. So he went there and they told him that it's in the basement and it'd take 6 months to get it. So he breaks in with this girl and his friend and this guy that knows the hospital, and they break into this building. And of course it's got ghosts, and they start, and by the end, it was kind of a mystery type horror type movie. It was good. I liked it better than the other one. No, with Them was good, but it's better than some that I've seen. I'll shut up. Let y'all work. You just have one of those days that you just can't think. Y'all don't have days like that? You just don't think like this. Okay. Now don't stop because you can do this. You got to remember, you're rewriting things, and remember your definition of a logarithm. Of course, if you don't know the definition of logarithm, then you don't know what to do. It's still raining though. I think it just rained, didn't it? Didn't we have another downpour while we were in this class? Y'all finished? Or are y'all sitting there staring at it? Which one is it? You finished because you got tired of sitting there staring at it? Alright. LOG 3x, oops. Of 3x plus 2 times what? Definition of logarithm. Y is equal to log base 10 of x. A log base A to the y, so that's what? 10 to the what? First power is equal to what? 3x plus 2 times x minus 1. And I'm sorry, where did y'all learn how to do this? Algebra 1, Algebra 2, FOIL method. Minus 3x plus 2x is what? Minus 2. 0 is equal to 3x squared minus x minus what? Let's see if we can use the reverse FOIL. 1x, 3x. Well,
1, 12, 2, 6, 3, 4. I don't see it.
That means you get to use what?
Complete the square. 3x squared minus x minus 12 is equal to 0. 3x squared minus x plus blank is equal to 12 plus blank. Factor out 3. X minus 1, x squared minus 1/3. Oh. X squared minus 1/3 x plus blank is equal to 12 plus 3 times blank. 1/3 divided by 2/1 is equal to 1/6. 1/6 squared is 136. And that's going to give you x minus 1/6 quantity squared is equal to 3. We bust that into twelfths. And that'd be 144 twelfths plus 1/12. X minus 1/6 quantity squared is equal to 145/12. Take the square root of both sides. X minus 1/6 is equal to the square root of 145/12. X is equal to the square root of 45, and the square root of 145, and 12, 4 times 3.
You missed the 3. That without 3, you gotta divide by it.
Oh, thank you. You're right. That'd be a 36. Thank you. Usually, huh? I know, that was gonna be, I was gonna have to rationalize the denominator. And that's a good indication sometimes that you're doing something wrong. So divide by 3, multiply by 1/3, x minus 1/6 quantity squared is equal to 145/36. 145/36. And that's gonna be x is equal to the square root of 145 plus 1 over 6. That's positive or negative 12.1. However they want the x or decimals. Well, wait a minute. Negative, it won't be the negative, will it?
That would be
Yeah, because that -1, yeah, so it's not going to be the negative, so just leave this positive right here. So that'd be what? 13.1 divided by 6, which is equal to what? 2.2,
sound good.
something like that. Again, 80% of this problem is what? Algebra that you've already done. Capiche? Let's see what other kind of problems we got in this section. I'm about to lose my patience today. Let's see what they get. Yeah, they got the plus. See, they took the negative off. Can't have a negative. Well, you can have a negative if the number in there is bigger and makes it a positive. You can have it, but this one, that 1
That 1 right here didn't do squat. It's gonna still be a negative. Okay, so that's that page. I'm not going to cover inequalities, because you don't need to know them. This one, write this one down. And the reason I want you to write this one down is because you're going to see this a lot in calculus. E to the -2 natural log of x is equal to 1/16. Bring the power rule out. And how did they get that? How did they go from here to here? I'm asking y'all. I'm not asking me. I'm asking y'all.
Natural log of E is 1.
Well, you're getting close. You're getting close. How about changing it back to log?
The natural log and E cancels out each other out.
Exactly. Natural log and E, because what is natural log? Log base what?
E.
Log base E to the E is 1. And it's in those original definitions that I gave you. So you need to make a note of that. Anytime you take the natural log of E, you're going to get 1. Or log base E of E is 1. So you need to write that down right there. And then it just changes it to an exponential, which is a pre-algebra problem. And there's no other way to solve it. That's, again, why I'm showing you the examples. If I knew there was another way to do it, I'd tell you. It's kind of like accounting. There's no way to not get a surplus or a debt. There's no way. You're going to get one or the other. So that's not a test question as much as it's a question you're going to see later on. But it could be a test question, not like the other ones. But that's another one, just more complicated. I wouldn't put that on the test, but you might see one in the homework. And again, they're using what law are they using? They're using a definition here to get the natural log of x. That blue right there is there it is right there. All right, but what did they do here? What's that minus mean? Division. They're rewriting. And then, of course, you got the natural log. And if you have the natural log equal to the natural log, then you can set this equal to what? Those two. So that's, yeah, I'm not going to cover these. When you get to Calc 3 and Diff-EQ, that's you working. There's hardly any problem that you don't work that doesn't have a log or a natural log in it. Okay? Question? Okay, we're done with this section. All right, so what does that mean? Yeah, we're done for the day, and we're done what? For the chapter. So that means you're going to have a chapter 5 test next week. So be looking for it whenever y'all come back. Tuesday, we'll go over some more questions and let you look at the test, and then you'll take it probably posted Tuesday. Okay? Y'all have a good one.
You too.
Oh, I forgot to get the roll. I'll just say everybody's here.